Alrighty, here's a quick video on using the Wokwi logic analyzer to see your inputs and outputs over time. Here's a stochastic multiplier. Here's a pseudo-random bit stream generator. Down here are some comparators and an AND gate. That's not so much what we're about. So this is a bit ugly the way it is, but it should get it across. So I'm going to start the simulation. And notice I've wired the outputs and an input, the clock that I'm interested in, to the logic analyzer. So I'm going to start the simulation, and I want to see how this is going to go. So I'm going to just say I'm going to try to multiply a 1 times a 1. Then I'm going to hit reset, hold it for a little bit, and then let go. And oh, my mistake. The clock was set incorrectly, so I have to come back here. So I'm just going to stop this and start it again. And just so I know where to see it, you'll see later, just hold the reset button for a little bit and let it run. I've got a clock frequency of 10 Hertz. All right. So we'll just stop, and it automatically saves the file name, Wokwi Logic 1. So then this tells you how to use a logic analyzer, and also where to get the pulse view and how to use it. All right. Which I'm going to start now. This is from an older simulation. I'll just get rid of that, and then click here, and then it's important to import value, change dump data rather than open the file. This is the one in question. It's also it takes a lot of samples per second, so if you plot every sample, you can crash your machine because it's just so much data. So what you do is you downsample it. So I'm going to take whatever my sample rate was and reduce it by 1,000. And then I'm just going to press OK. Now, if all of a sudden it's taking forever to draw your circuit's response, you probably didn't downsample right, and it might crash. The only way it'll keep doing that, even if you exit the program and come back in, it'll remember the last thing you did, and it'll keep crashing. So you have to go back and, let's say, and delete the original file, or actually just rename it. Then it'll come back normally. So this was what was going on before. This is me hitting reset. Right, I can just zoom in, and in this case, this is the stream. When I'm having 0, right, this will be 16 clock cycles, and then it'll go high for 1 clock cycle, and then high for another clock cycle, which might be unexpected. And yeah, I'm trying to encode a 1. So what's going on there? Where are we? So for some reason, even when it's 0, it'll spit out a 1 there. This extra 1. So anyway, ANDing these two signals will create a 1. So I'm getting a 1 for every 16. So the probability should be, Anyway, this is where I'm having a little bit of trouble interpreting things. But that's how you look at data in time. This is the pseudo-random bit stream generator, and you can see that it, every 16 cycles repeats. I'm thinking the issue is we needed to have a 32-bit long stream rather than 16. And I think that will make some of the problems go away. But logically, it's doing what we told it to do. And so what I want you to do is put these kinds of plots in your report. And on the website over here, it tells you how to change the values somewhere. So change the names so that it's not just logic that you can actually, you can change it right there, right? So that can just be clock. This is, that's A encoded. That was B encoded. This was pseudo-random bit stream. And if we want, we can just call this X for multiply. All right. Not quite sure how to zoom in here, but I'll leave that. Like it zooms in on the axis, but I would rather see this bigger. But anyway, that's pretty good.